Now I'm pleased to introduce Dr. Kfir Bar, who is Chief Scientist at Basis Technology. He has many years professional experience in NLP, multiple disciplines, statistical machine translation, machine learning, deep learning, ontologies, language generation. He has worked to support national security and counterterrorism mission for many years, both as a technologist and as a direct participant. I also want to mention that Kfir is one of the organizers of a new data consortium focused on Semitic languages, developing a new suite of tagged corpora from contemporary sources. So if you work in Arabic or Hebrew and you're interested in this new consortium and joining it, please get in touch with one of us after the event. So, Kfir, welcome.
Hello, thanks. Can you hear me, I guess? So thank you so much, Carl.
Yes, we can.
Yes. So as Carl said, I'm the Chief Scientist at Basis, and my plan for today for this session is to cover some topics related to emotion detection, and in text specifically, and then talk about how it may be related to misinformation. So the word emotion was coined sometimes during the 18th or 19th century. As you can see here in red, there are mentions of the word emotion in books over times by Google. And then around 1830, I would say, it replaced the word passion. And you can see here in blue. And then it became the concept of what we are familiar with today, which is it's defined as a biological state associated with thoughts, feelings, responses, and degree of pleasure or displeasure. And this is probably the most common definition, but there is no clear consensus about it. But based on this particular definition, how do we express emotions? So we express emotions through facial expressions. Obviously, that's the most common way of expressing emotions, I would say. Even in animals, even they express emotions through facial expressions. There are a number of studies that show that in gorillas, dogs, and others. Voice expressions, specifically prosody, right, which is a collective definition for intonation, tone, stress, and rhythm. And we use all these to express emotions, typically in speech, hand gestures, obviously, and we express emotions through art, and definitely in writing, which is the main topic of this session. So how emotions or emotion detection is related to misinformation, I would start by saying that it's an active research area, and some preliminary results already show that emotions are distributed in a slightly different way in fake and real messages. But I want to get back to that later after we talk about some other things. So first, I want to talk about how we represent emotions computationally and how we detect emotions in text. So generally speaking, there are two main approaches for representing emotions. There is the categorical approach, which is basically representing emotions by categories, labels, or names. And there is the dimensional approach, where we represent emotions as three-dimensional vectors of real values, which I will explain momentarily. So let's start with the categorical representation. And here we represent emotions as categories, as we said, like sadness, happiness, joy, anger, and so on. But keep in mind that that might be tricky, because it seems like emotions are captured differently by different cultures. So Paul Ekman is a famous psychologist here in the picture. He claimed that there are 6 basic emotions that are recognized by potentially all cultures. although sometimes in a slightly different way, but it's still recognized. And those are the 6 basic emotions of Ekman. You see here anger, joy, surprise, disgust, sadness, and fear. Now, those are not the only emotions that we have, right? So we have more emotions, but according to Ekman, at least, these emotions are considered to be complex and rather than basic emotions, in the sense that they're expressed, when they're expressed as a combination of the other emotions. Could be basic emotions as well as non-basic emotions. Another way to represent emotions is the dimensional approach, using, as I said before, a 3-dimensional vector, simply 3 numbers. And the motivation for doing this is in the belief that affective states, those biological states we talked about before, they should be probably measured on a spectrum rather than discrete labels. And it's because we probably have a large number of affective states, of biological states, representing feelings, I would say even potentially infinite number, for which we don't have labels or names. So I thought about it, and it's probably more like colors, right? Colors are represented by RGB, red, green, and blue, and we have different levels of red, green, and blue, and then we combine them together, and then we get a color. But for most of those combinations, we don't have names. I mean, if you look at the left side here, I mean, we typically call all that part blue, right? But it's not really just the same color. So emotions are probably something more like that. And the dimensions that we have there are not red, green, and blue, are valence, arousal, and dominance, VAD, which I will explain now in slightly more details, each one of them. So let's begin with valence. So valence is the dimension that measures how pleasant the emotion is, right? So it goes from unpleasant, pleasant, and as an example, take joy. So joy is a high valence emotion, obviously. So there is another dimension, as we said, arousal or excitement, some people will call it, and it measures the intensity of the emotion, and it goes from calm to excited. As an example, if you take those 2 emotions, basic emotions, we have anger and sadness. So both of them are kind of negative emotions, right? So they are on the negative side of the valence dimension, the valence axis here. But anger is has a higher arousal value, right? So we're more excited when we angry, and when we sad, we're less excited. So we're more calm, I would say. So it's a good way to distinguish between those 2 particular negative emotions. We have another dimension. The 3rd dimension is called dominance, and it usually refers to the level to which the person feels influence over a situation or control the external environment during the emotional experience. So as an example, take fear and anger, both are negative emotions. I didn't put them on the slide, actually, just thought it's too busy, but fear and anger are negative emotions, obviously, so they are on the lower side of the valence dimension. But fear is more submissive, so we have less control when we fear, and when we angry, we have more control, obviously. And we typically set the range of values for each one of those dimensions. So for example, here they all go from -1 to +1, but it doesn't really matter what numbers you pick, as long as you're consistent across the different dimensions. By the way, there is another dimension, the 4th dimension, representing emotions, called novelty or familiarity, but it's rarely used, so I'm going to skip that, and we don't use that in natural language processing. Russell and Mehrabian, they're both psychologists, famous psychologists. They came up with this great, interesting model that provides mapping between VAD values and emotional labels. They ran many experiments, and that was the conclusion. This particular model, it's a famous model, and I mean, it looks a little bit different than the system that I showed you before, but basically it's the same system. So you still have dominance, valence, arousal. Each one of them goes from -1 to +1. And specifically here, you can see joy. According to Russell and Mehrabian, joy has a relatively high valence value, arousal value, high arousal, and high dominance, right? So you can see that. If you look at anger, so it has much smaller valence value, but the same level of arousal and dominance. Fear and surprise, both are very similar to anger and joy with respect to valence, but fear and surprise has a lower, dramatically lower dominance value and slightly less arousal. Sadness has an even smaller arousal value, and then disgust is slightly more complicated, somewhere between fear and anger with respect to the dominance and arousal dimensions. So those are the 6 basic emotions of Ekman placed on this Russell and Mehrabian system, but there are more emotions that were mapped to VAD like that, more complex emotions, and I encourage you to go to the original paper with the link in previous slides. It's a paper from 1977, and it's still very relevant. Actually, it's very, very useful for emotion extraction and NLP. Specifically, what you can do is that giving a new affective state represented by VAD values, we don't care for now how we got these VAD values, but once we get them, we can, I mean, like the blue dot here, right? So using this model, we can calculate the distance between that particular VAD point to all the other points representing the basic emotions, even other complex emotions, and then determine the relevance of each basic emotion to that particular situation based on their distance. And that's pretty useful. So measuring emotions with VAD by humans requires, I mean, how we collect that information from humans, VADs, right? Those 3 dimensions. It requires a technique for collecting them using a form. So this is the form that people are usually using, and it's called SEM, or self-assessment mannequin form. And each row here, it's a simple form, right? So you see 3 rows, and each row here represents one of those dimensions. So you have the valence, first row, then we have arousal and dominance. And when a person needs to assess an affective state, he or she can use this form, then choose one value out of 9 options in each one of these dimensions, each one of these rows, and that's it. And then we get those numbers. We can collect numbers for the same emotional experience. We can collect those values from multiple annotators, multiple participants, and then take the average values and so on. Okay, I think we are now familiar enough with the VAD model, and we understand how we can interpret those values to emotional labels. So I think we're ready to talk about how we detect emotions in text. So I'm not going to go into too many technical details here, but at a higher level, I would say that for text, the more general task is typically referred to as sentiment analysis, right? So you're probably familiar with that. And it's one of the most common NLP tasks. And it's about taking a text like this one. I can't wait anymore. It's frustrating. I would like to cancel my subscription. So, and then we classify that text into one of those labels. So it could be positive, neutral, or negative. And but only those 3 labels, right? So in this case, probably negative. In emotion detection, we want to know exactly which negative emotions are expressed. So maybe frustration and anger in this case. Alternatively, we can work with the VAD model, and that is predicting the valence, arousal, and dominance levels, maybe in percentages, normalized somehow, as you can see here. And then we can use that. We can use those values, the predicted values, to map them using Russell and Mehrabian model. Can map them to the basic emotions. Okay, so emotion detection is only one flavor of the general sentiment analysis task. There are others such flavors. So we have the fine-grained sentiment analysis, which is basically like sentiment analysis, but usually we use 5 labels instead of 3. So, I mean, in addition to the positive, negative, neutral, we also have very positive, very negative. We have the entity-based sentiment analysis, and it's when we detect the sentiment expressed toward a specific entity mentioned in the text. And similarly, we have aspect-based sentiment analysis. It's where aspects, aspects are some important topics in the specific domain that we care about, for which we want to get the sentiment from the text. So while sentiment analysis has been mostly solved by rule-based systems supported by some effective lexicons, right? So lexicons of good words, like positive words, negative words. That was mostly in the past. A more modern approach is to use machine learning. And with this approach, obviously, we train a machine learning algorithm using a collection of texts that were previously annotated with sentiment information, so positive, negative, and so on. And with emotion detection, we do the same thing. So we train a machine learning algorithm with a bunch of text annotated for emotional categories, like what you see here, anger, joy, and so on. By the way, we can take a multi-label approach as well. It makes things much more complicated from the machine learning algorithm side, or we can go to the VAD model, which is about predicting those 3 numbers, right? So the model is trained to predict those 3 numbers, and then at runtime, we can use those 3 numbers to map them using that model to different levels of the basic emotions or other complex emotions that we care about. To train a machine learning model, obviously we need data, right? So we need annotated data. So as I said, emotion detection is an active research area, I think for several years already, and there are a number of data sets that are publicly available. And this is a partial list. There are more, and even not just in English, in other languages as well. So you can see here at ICER, those are all categorical emotions, so labeled specifically for those 7 emotions. And then the SEMEVAL 2017, we have 6 emotions, we have 4 emotions after 6 emotions, 13 emotions. So you can see that data sets differ in the number and type of emotions they cover. There is still not agreement there. For VAD annotations, there is only one data set that I'm familiar with. It's called EmoBank from 2017, and it provides VAD annotations. It contains about 10,000 short sentences, not really just sentences, actually tweets, short text, Reddit posts, and each one of them is annotated with VAD values that actually are the averages of values assigned by 5 different annotators. And in order to annotate those texts, they use the SAM form I showed you before, the self-assessment mannequin form, but they use the short version of 5 categories rather than the full 9 version. So we ran an experiment with transfer learning using BERT, a very simple model. So using BERT as the base model, and then on top a number of layers for doing regression prediction, specifically using the EmoBank data set. After removing some of the text that had high or less agreement between the different annotators. And then the model calculates those particular 3 values. However, there is no relevant evaluation metric that I can show you because this is more like a regression problem. So it doesn't really predict any labels, but I do want to show you some examples of text outside of the training data, outside of the data set at all. So those are posts from Reddit, and we predicted the VAD values using that particular model. So you can see some examples. I just picked them, and you can see here specifically so that you can get the feeling of how this is working. So Gorgeous here got valence of 72. The numbers are normalized between -1 and 1. This text have an alternate account, a post certain loosely connected story form. It's not going well. So that got valence value of almost 0, slightly less than 0, but it still can go all the way to -1. So it's still not very negative. For arousal, so this is relatively high arousal text, and this is a very low arousal text, very calm. Okay, so before we wrap up, I want to touch on 2 main topics. So first, I want to talk about the challenges that we face when working on sentiment analysis and emotion detection specifically. And then I want to get back to talk a little bit about some results, recent results, just as a title for how we can connect emotion detection and misinformation. So the first challenge I want to talk about is ambiguity, which is probably one of the most common challenges of any natural language processing task. And this is related to the many different meanings that one text may convey. For sentiment analysis specifically and emotion detection, negation structure specifically might be a challenge. You can see here, right, this is not good. So good is a positive word, but not good gives us the opposite polarity. So we need to make sure that we know how to handle those specific negation structures. But sometimes, the structures are very complicated, and sometimes they're even implicit, right? So this is like, this specific sentence carries a negative sentiment, I would say, but there are no negative words used at all. So that's definitely a challenge. The other challenge I wanted to bring up is the perspective. So for emotion detection specifically, the perspective is even more important than sentiment analysis. Sometimes the emotions are expressed differently by the writer and the reader of a piece of text. So for example, take this sentence, France defeated Croatia in the World Cup final, right? So I was for real, and it's a report. So probably the writer doesn't express any emotions, but the reader, it really depends, right? So if you're a France team fan, probably you're very happy about that. But if you're from Croatia, not so much. So yeah, that's definitely a challenge for emotion detection. Figures of speech, definitely a challenge. There are many of them, and they're making our life much harder. When we talk about natural language processing in general. So metaphors, in our case, it's about metaphors describing an emotion, but taking the reader to a creative, completely different imaginary space where the algorithm needs to figure out the most relevant characteristic of that space to the described emotion, right? So like tornado here. And sarcasm, obviously, right, where we say things in an opposite way, and that makes our lives much harder, as you can see in the examples here. But I would say that recently the research community is trying to address these particular challenges specifically, directly, and not just taking an end-to-end data-driven approach. There are many new shared tasks about sarcasm detection, not just in English, but in other languages as well. And I mean, then we can use such models in a more, in a pipeline for solving that particular downstream task of emotion detection. Finally, here, as a last challenge, I want to mention prosody. Although it's not really an NLP problem, it's like, it's about how we pronounce words, but that may affect, the emotions that we can extract from the text. Because if you take this word, for example, if you only have it in writing somehow, okay, right? There are many ways that we could pronounce it, which will reflect different emotions, right? So if you ask me, you want to go catch a movie, I'll say, okay, right? But what if you ask me, you want to go wash the dishes? I'll probably say, okay. So that's definitely a different emotion that we express, and we don't have that in writing. So that's that calls for multimodal kind of approaches where we analyze, process text and audio, text and image and video for extracting facial expressions. And that's there are data sets for that publicly available, and that's a pretty cool topic. All right, so before we really wrap up, so back to misinformation. As I said at the beginning, there are a number of works that already show some correlations between the expressed emotions and the authenticity of the text. So I'm not going into too many details, but there is a work here by Pestchen and others who showed recently, 2 years ago, that the titles of fake news articles, and specifically we're talking about titles, and this thing, titles, we see that in other works as well. And they say that the title of fake news articles carry more negative emotions, and like emotions on the lower valence side. And obviously that's not always the case, right? Because it's, there are some positive fake news articles, but it was significant enough in a large collection of fake news data sets that they could actually claim that. And following that work, there is another work still in review, I believe, very recent, and this idea in particular was further developed. They took, or they actually looked at two different emotions or emotion expressions. One is by the author of the text again, and also, by the way, specifically taken from the titles and not from the body of the text. The body of the text may contain so many different emotions, so focusing on the titles makes sense. And they also took the emotions expressed by the readers through their comments, using data-driven approach models like the ones that we talked about here. And they show that there are more disagreements between the emotions expressed by the writer of the text and the readers in fake news articles. And again, that was statistically significant for that particular research, but this is, I'll consider all those things as preliminary results, but definitely an interesting approach, and potentially I would say that it's not going to be the only tool for detecting misinformation, right? So it might be just some features that we can extract, emotional features, and then use them in a downstream model for detecting fake news. So that's the idea, and that's something that we would like to explore in the near future. So I think that's what I had for you today. Thank you so much. Happy to take any questions.
Thank you, Kfir. We're running tight on time, so I think we only have time for one or two questions, but let me take one from Carrie, who asks, how do you train or tune on words that are current terms that have a good connotation, but as the trend grows stale, the words turn to have a more negative or make fun of connotation? I'm thinking of a teenager saying, X term is so 2018.
So yeah, that goes back to the, I would say, to the figures of speech problem. It's even, yeah, worse, but basically that's Yeah, that's a major problem. So how we address that, focusing, I would say that focusing specifically on solving those particular problem with data first, and then try to integrate that into a downstream pipeline for emotion detection. That's the way I would try. But I will say also that that's not going to be perfect. It's a very difficult problem in NLP, and this is why we're not expecting anytime soon to get, you know, great results like part of speech tagging in English.
Javier asks if any data sets with emotional categories or VAD are available in Spanish.
Yes, yes. In fact, VAD in Spanish, specifically, those are very short texts as far as I remember, but there was a shared task involving Spanish, English, French as well, where VAD annotations are available. I can look them up and share later.
Danila in Sweden asks if you think it's possible to do entity sentiment analysis where the entity is abstract and not a named entity.
I think so. It's more related to aspect-based sentiment analysis. So in aspect-based sentiment analysis, you first automatically find what are the main aspects. So it's similar here, right? So we could find the abstract entities basically. It's more difficult, and it's usually divided into two subtasks. So first, when going to a new domain, try to find those aspects, or in this case, abstract entities. And then the second subtask is about extracting the sentiment that is expressed toward those aspects. And sometimes we do them, you know, as a joint model because they may affect each other.
Tien asks what you think about combining emotion detection with understanding the context in which the statement is made.
Yes, absolutely. So I'm doing an experiment right now. It's like part of a research that I'm involved with and we're building a data set for that. So like trying to detect the emotion that is expressed in a reply to a specific tweet. So we do consider the tweet, the original tweet, as an input and not just the reply tweet. We also try now to add other replies in the same thread. I don't know what to say about results yet, but it's still a work in progress. But I think there's a lot of potential there. Any context would help.
And Ludovic is asking whether any of your work in this area is implemented in Rosette, and if so, how it can be leveraged.
So not yet. This is like this is a research project, and we are running experiments now. So that's the stage. At some point, we'll be able to come up with a new beta version, but this is not available at the moment.